Hi, how's it going? Welcome to Code with Z. In today's video, we gotta go from this position all the way to this position. Why? Well, that's because this is what LeetCode 62 unique paths is asking us to do. As you can see, it says there's a robot on an M by N grid, basically what we have here, and the robot is initially located at the top left corner. Again, what we have here. Then, this top left corner is represented by grid at the row of 0 and at the column of 0. So at the row of 0 and at the column of 0, because the index of this row is 0 because it's the first index, and the index of this column is also 0. And then we're told that the robot tries to move to the bottom right corner, basically what we have here. And bottom right corner is represented by grid at the last row and the last column. If we check last row, last column. And then we're also told that the robot can only move either down or right. That means we can't go up or left. We're only given the two integers m and n, and we gotta return the number of possible unique paths that the robot can take to reach the bottom right corner. So basically, how many unique paths are there to make this robot go from here all the way to here? Well, let's figure that out together. So first of all, how many unique paths do we have if we start from here to this cell? Like, in how many unique ways can we actually get here? Well, we know we can't go up or left, right? And because we start from this position, we can only go to the right to reach this position here. For example, if we go to down, we will not be able to come back up because there's no up option, right? So the only way to reach this cell here is to start by going to the right in the first place. So the number of unique paths available to reach this cell is gonna be 1. If we start from here and we want to get here, there's only one way to do that. And you might be like, Z, why are you calculating this? Well, we can calculate the number of unique paths required to reach each cell. And if we check, our goal is also a cell. So if we actually figure all of these out, we can figure this one out. And the number of unique paths available for each cell is actually dependent on the previous ones. Like, for example, if we start from here, the number of unique paths available are gonna change. But because we start from this position, we know that this cell has only one unique path. Well, what about this one? If we think about it, it's gonna be the same thing. There's only one unique path to reach this cell. There's no let's go here and then 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 here, because we can't go up or left. The only possible way to reach this cell is to just go right in the beginning. So there's one unique path to reach this cell. What about this one? Well, if we check, again, it's gonna be the same thing. There's only one unique path to reach this cell, and that's by starting to go from here to here, meaning we only go right in the beginning. So this is also gonna be 1. And I think you can slowly see a pattern. All of the cells that we have here are gonna be 1. Basically, all of the cells in the same row that we start at are gonna be 1 because we can only go to right and down. So if you wanna, for example, reach this cell, you should, it's not even optional, you should start by going right in the beginning. Otherwise, if you go anywhere else, you're not gonna be able to reach this cell. So we only have one unique path. So far, we've concluded that there's only one unique path for all of the cells in the same row that we start at. Let's see the case for the column that we start at, which is this column that we have here. So if we start from this position and we wanna get to this position, how many unique ways are there? Well, we can go from this position to this position by going down, so that's one way. Or we can go right, this is allowed, right? We can go to right. So we go right and then down, this is also allowed. And then we can make a left. Oh wait, we can't make a left. So there's only one way to reach this position as well, and that's by going to down from the beginning. What about this position? Well, if I want to reach this position, I can go from this position to here by going down. Or I can go from here to here and then, oh, I can't make a left. What about if I make this and then this and oh, I can't make a left? So the only way is to go from this position all the way to here by just going down and down. So the number of unique paths available to this cell is also gonna be 1. Oh, would you look at that? All of the cells in the row that we start at and all of the cells in the column that we start at are gonna have the value of 1 meaning there's gonna be only one possible way to reach them, so the number of unique paths available to them is gonna be 1. Now, what about these cells that we have here? Well, because we've already calculated these, we can easily figure that out. Well, let's see. If I want to get to this position, I can do a right and then a down. Or I could do a down and then a right. So that's going to give us 2, right? So there's 2 unique paths to reach this cell. I can't make a right, a down, and left because left is not possible. So the only paths are going from here to here or going from here to here. So this is going to give us 2. Well, if we actually check, if we add these 2 numbers together, like so, that's going to give us the answer. So that's going to be how we calculate the number of unique paths available for each cell. Let's try it for this one. 1 plus 2 is 3. Well, if we check, there's only 3 unique paths available to reach this cell. We can go from this position to right, and down, or we can do right, down, right, or we could do down, right, right. And that's going to give us 3 unique paths. And to calculate the number of unique paths available for this one, we're going to say 1 plus 3, like so, and that's going to give us 4. And then we're going to say 1 plus 4, and that's going to give us 5. And then we're going to say 1 plus 5, that's going to give us 6. And then 1 plus 6, that's going to give us 7. Then we're going to do the same thing literally here. We're going to say 1 plus 2, that's going to give us 3. Then 3 plus 3, that's going to give us 6. Then 6 plus 4, that's going to give us 10. 10 plus 5, that's going to give us 15. 15 plus 6, that's going to give us 21. And 21 plus 7, that's going to give us 28. And that's going to be our answer. So there's 28 unique ways to reach this cell. For example, one of them is going to right, 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 and then down, down. Or we could do this, like so. Or we could do this. There's 28 unique paths available, and we figured it out by going from this to this, to this, and then to this. And this is a dynamic programming approach because we broke down the problem into smaller problems like so, and then we stored those answers and we used those answers to solve our bigger problems like so. This is going to be all of our algorithm. We first make this grid out of the m and n that were given to us. Then we fill the first row and the first column with 1s. And then we're going to use these values to calculate anything that remains, like so. Now, let's code this in the simplest way possible. Alrighty, so we were given how many rows we have, which is represented by m, and we were also given how many columns we have, which is represented by n. So let's first define our grid. We're going to say grid is equal to array of m. In the slides, the grid was empty, but we're going to fill it with zeros, and then we're going to say map. We're going to loop through them. We're going to also fill with zeros. So this is basically gonna make our grid. Then we gotta fill all of the cells in the first row and all of the cells in the first column with 1s, just like we saw in the slides. So we're gonna say for let I being equal to 0, and we wanna keep on looping as long as I is smaller than m, and we wanna increment I on each round. So here we're gonna get each row, we're gonna start with the rows, and we're gonna fill the first cell inside of them with 1s. If you check, as you can see in the picture, we're gonna get each row like so, and we're gonna fill the first cell inside of them with 1s. Here we're gonna say grid at the index of I. This is gonna give us all of the rows and the first cell, and we wanna make that be equal to 1. That's gonna make all of these be equal to 1. And then after this, we're gonna have another for loop. We're gonna say for let j, for example, being equal to 0, and we want to keep on looping as long as j is smaller than n, and we want to increment j on each round. Here we're going to say grid at the index of 0 to give us the first row. The first row has the index of 0, and we're going to loop through our columns like so, and then this is also going to be equal to 1. And that's going to make all of these cells that we have here be equal to 1. And we're almost done. Now we need to fill out the rest of the cells. So we're going to say for let row, for example, being equal to 1, y1, because we've taken care of all of the cells in the first row and the first column. So we're going to start from the second one that has the index of 1. So we're going to say for let row being equal to 1, we want to keep on looping as long as row is smaller than m, and we want to increment row on each round like so. Here we're going to have the second loop because we want to loop through all of them. So we're going to say for let column being equal to 1 for the same reason, and we want to keep on looping as long as column is smaller than n, and we want to increment column on each round. Here we're gonna have one simple line. We have to say, if you wanna calculate the number of unique paths available to this cell that we have here in the picture, you gotta add this cell with this cell. So let's see how we can do that. We're gonna say grid, row, and column. So for example, we're here, literally in this position in the picture here. We wanna see how we can calculate the number of unique paths available to this one. So we gotta say add this with this. So here we're gonna say this is equal to grid, the cell at the previous row. Let me drag this to the left. The cell at the previous row and the same column plus the cell at the same row but previous column. Now what does this mean? Well, we said the number of unique paths available for this cell here, as you can see in the picture, is gonna be this plus this, right? Well, here we're gonna say add the number that we have inside the cell in the previous row but the same column plus the number that we have in the cell with the same row but previous column together, and that's gonna be the answer here. That's basically what we're doing, and that's gonna be it. At the end, we gotta return the number of unique paths available. That's gonna be the cell at the last row and the last column. So we're gonna say return grid at the last row. So m-1 is gonna be the index of the row, and n-1, that's gonna be the index of the column. Now let's run it. I hope I've not made any typos. I've actually made one, sorry for that. This is gonna be like so. I don't know why I added this parenthesis here. That's gonna be it. Let's run it. Sorry for that. And yep, we got accepted, both of them. Let's see if we can actually pass all of the test cases. Moment of truth, we got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.